So an anomaly, sorry, yeah? They'll be the same as the group that, yes, of whatever the non-abelian group that A is or the gauge field is from. Yeah. So the anomaly is that equation. In fact, I don't want to waste valuable more space. So under this way of looking at it, an anomaly is basically XA. Of course, these depend on X. Acting on gamma of A is going to be something non-zero. So let's call it G. And it will be a functional of the gauge field. So this isn't so far any big deal. It's just saying this covariant divergence isn't zero. Let's call it something, and let's call that something G. But now the commutators of these x's imply that XA commuted with GB of A is equal to F ABC GC of A delta of X minus Y, if that depends on X and that depends on Y. Because it's a functional variation at A of X, this will give, this thing will be zero everywhere unless Y equals X, in which case you get a delta function. And this relationship is equivalent to saying delta U of G of dA, which I'll define in a minute, minus delta V acting on G of UA is equal to G of the commutator of UV with A. So what the heck do these things mean? Delta U is the integral of over X of UA XA. So I take this operator. Remember, this is a function of the space-time point, so I integrate over space-time, and that's delta U, or delta V. And G of UA is defined to be the integral over X of UA GA of A of X. So if you integrate both sides, integrate over X times UA and over Y times dA, this relationship turns into that relationship. And so one can then ask, what is it that solves these equations? In other words, one can say this is what you get when you have an anomaly, and then one can ask what are the possible solutions to these equations. Maybe I should back up. It's not quite the anomaly yet. So what would be a solution? So let's take this, call it star. I think I'll just go through it to rub off less. I've only got about 5. So if I just look at it from a functional integral viewpoint, I have this functional G, and if there is an anomaly, then these x's can act on G like so, and can give me a set of equations. So I can ask, yes, V comma A, delta V, U comma A. Yeah, that's the functional argument where this thing here is that thing there, and so defined. So it's like you smeared out G over some gauge parameters and smeared out X over some other gauge parameters in space-time. That's basically what this is. The idea of this operation is to smear out over the delta function. So I've integrated times some gauge parameter over space-time for X, and likewise over G as well. So the question we can ask is, what are the solutions to star? Remember, G is a signature. There is an anomaly. If there's an anomaly, G will be 0. So one solution is G of VA, say, is delta V on G hat of A. In other words, maybe this G is a gauge variation of some local functional. Then you'll get delta U, delta V minus delta V, delta U on that local functional, and it will just tell you that the commutator of delta U and delta V is just G of those commutators, or G of the commutator of U and V. What is a local functional? It means the same as an action. It's the integral. Everything is at the same point instead of at two different points. But this is not, let's see, it's not the most general solution. Some solutions to that star equation way over there are not gauge variations. If there exists a solution that is not delta V of some G hat, then we have an anomaly. Then we have a bona fide anomaly. The star relations are called the Wess-Zumino consistency condition, or just often just the Wess-Zumino condition. So one such solution is that G of VA is equal to the integral over some manifold of dx 2n of this omega 1 thing, of this non-abelian anomaly structure. And you can show, which I won't do here, but I'm happy to let people see the arithmetic unless they make you do it as a homework, that if delta U of this thing minus delta V of the same thing with U and V switched is indeed equal to G of this commutator of A, where G now, maybe I should call this G tilde because it's the solution. So in other words, one solution is the variation of some local functional. Another solution is this thing. This is not the variation of a local functional. This is a local functional, but it's not the variation of something. So if you do the variation of this and subtract it with U and V, you can show by, in my view, about 4 lines of manipulation that you get a commutator in here, or rather a commutator in there. And so the non-abelian anomaly obeys the Wess-Zumino consistency condition. And in fact, non-abelian anomalies